Students, in class 9, we have done the chapter called as atoms and molecules. And in these atoms and molecules, we have discussed about Dalton's theory in the previous session with the help of the experiments. Now, in this session, we take up the next part of Dalton's theory, that is the outcome of the Dalton's theory, which talks about laws of chemical combinations. Laws of chemical combinations. And in this laws of chemical combinations, one of the laws is law of conservation of mass. Number 2, law of constant proportion. And the third one, which is called as law of multiple proportion. In this law is very, very important. And in this law, that is the law of conservation of mass, what does the statement say? The statement says that matter can neither be created nor destroyed by any physical nor chemical means. That means neither with the help of chemical reactions nor with the help of physical changes we can change matter. Now, let us go for the experimental evidence for this part. And what is the experimental evidence? We will perform a chemical reaction and prove it. But what is the most important point here? If matter can neither be created nor be destroyed, tell me student, matter has got some mass or not? So, when we perform a chemical reaction, the mass of the reactants and the mass of the products both should be equal. If that is so, that means law of conservation of mass or matter is correct, because no new matter is formed, no matter is lost. So let us go for the experiment now. What is the experiment I am going to show? It is a double displacement reaction. The reaction of lead nitrate with potassium chromate. And here I have those chemicals in front of me. Here I have lead nitrate. I take the lead nitrate, okay. I take the lead nitrate in a test tube and prepare a solution of it. I prepare a solution of it. How? I have taken the distilled water, add it, dissolve it, okay. See here, I dissolve it. It is dissolved. Can you see? I am not able to see any more of lead nitrate particles, completely dissolved. Now, I keep it here. I take now another test tube, and in that test tube, I will be taking potassium chromate. I take up potassium chromate. I take potassium chromate. Taken potassium chromate. Take distilled water. See here, students, dissolved completely. See, it's a clear, transparent solution. Clear, transparent solution. Okay. So now I have got the tube of them. Lead nitrate, potassium chromate. Now I am going to weigh them. Okay. By taking only a part of this potassium chromate solution and then weigh them. Okay, students? Fine. I take it. I've got the two solutions. Okay. Now see here, I am placing it over here and see the reading here. What is the reading? 127.34. Let me write it on the board now. I write here weight of beaker plus 2 test tube plus lead nitrate solution plus potassium chromate. What is the weight equal to, students? It is 127.34 grams. 127.34 grams. Right? I have not yet performed the reaction. Now I am going to perform the reaction. I will mix them now. See here, when I mix them and the reaction takes place, what happens to the weight? I am taking it. See here, carefully I put it over here. Within some experimental, what is it called, differences, small experimental errors will be there, but see here, still it is 127.32 or 34. So within the experimental error, you found that the mass was almost completely equal to 127.32. That means because of splash, some particles would have gone out. Imagine, we don't even think that, well, such a thing can happen. It has happened. So now I write here weight of beaker plus 2 test tube plus what is formed? Lead nitrate reacts with potassium chromate to form lead chromate plus potassium nitrate, and this is equal to how much? Again 127.32 grams, almost equal to 127.34 grams. Is it proved or not? Has matter got created? No. You may think, sir, mass got reduced. That means some matter has escaped. Matter has not escaped. That is because of the splash, we lost some particles during performance of the chemical reaction. Hence, law of conservation of mass holds good or not? Very much it holds good, stating thereby that mass of the reactant is equal to mass of product. I will just write this in the form of a chemical equation here, such that it is more easy to understand. So, weight of beaker plus 2 test tube plus lead nitrate solution. How do I write lead nitrate solution? Formula? The formula will now be written as PbNO3 whole twice. So, I write here PbNO3 whole twice plus potassium chromate, that was equal to 127.34 grams. Next, after the reaction, weight of beaker plus 2 test tube plus lead chromate PbCrO4 plus KNO3, formula only, it is not a question of balancing. KNO3 is equal to 127.32 grams, approximately equal to 127.34 grams, because loss in experiment. Proved or not, students? Yes, that means all our theory can be easily understood, proved with the help of experiments, and once we see this, it will never go away from our minds. I hope you understood it. Thank you, students.